Okay, in this video we're going to look at some examples where we calculate dot product given vectors in component forms. So here's the two vectors we'll look at, A, which will be vector 1, 2, 3, and B, which will be the vector -2, 3, -4. So the first thing we want to do is calculate A dot B. So A dot B, so that would be the vector 1, 2, 3 dot -2, 3, -4. So the formula, or the way you calculate a dot product of the vector and component form is, remember, it was A1 times B1. So let's multiply the x components plus A2 times B2, meaning multiply the y components. It's 2 times 3, plus A3 times B3, meaning multiply the z components. And then just work that out. So multiply those x components. That's -2 plus 6 minus 12. So that would be -8. So the dot product of A and B is -8, which tells me a little bit of information. If you remember from before, if you know that the dot product is a negative number, you know the angle between them is obtuse. So these two vectors, we know the angle between them is obtuse. We can actually do better than that. We can figure out what is the angle between A and B. So this is one of the more useful applications of a dot product. It allows you to calculate the angle between two vectors. So remember that the dot product, A dot B, is equal to the magnitude of A times the magnitude of B times the cosine of theta. Now if I want to figure out what the angle is between them, I'm looking for theta. So I'm just going to rearrange this equation, isolating for theta. So first I'll isolate for cosine. So cosine, if I divide both sides by the magnitude of A and B, would be equal to A dot B over the magnitude of A times the magnitude of B. Well, the magnitude of A we calculate, A dot B, we calculated as -8. So we know the numerator here is -8, and that's all over, this might take a little bit of work, the square, or the magnitude of A, but the magnitude of A, remember A was the vector 1, 2, 3, so that's going to be 1 squared plus 2 squared plus 3 squared. And then the magnitude of B, B, remember, was the vector -2, 3, -4. So that would be -2 squared plus 3 squared plus -4 squared. So working that out, you get -8 over, so this would be the square root of 14, and this would be the square root of 29 times the cosine of theta. And to get theta, you're just going to take the inverse cosine of this, -8 over root 14 root 29. So just work that out, put that in your calculator, and you will get approximately, if we go to the nearest degree, 113 degrees. So the angle between A and B, is 113 degrees. So you can use this formula here to calculate the angle between two vectors. So just by calculating the dot product and the magnitude of the two vectors, which is one very useful application of the dot product and something you should definitely know how to do. Okay, so here's another question that you could be asked. For what value of k are the vectors a and b perpendicular? So notice a is a vector 1, 2, 3, and b is a vector 2. K, I don't know the y component, and -1 is the z component. So we need to figure out what the y component is on this vector b that will make these two vectors perpendicular. So remember, and this is an important property of vectors, that a dot b is equal to 0 if the two vectors are perpendicular. Okay, so all we have to do is the dot product of a and b. So a was 1, 2, 3, dot product with 2k minus 1, and that should be equal to 0. So to calculate the dot product, we multiply the x's. So that's 1 times 2, which is 2, plus multiply the y's. So that's 2 times k, which would be 2k, and then 3 times minus 1. So that'd be 3 times minus 1, which would be minus 3. So we have 2 plus 2k minus 3 is equal to 0. So 2k, adding the 2 and the -3, that's 2k minus 1 equals 0. So 2k is equal to 1, and k would be equal to 1 over 2. So therefore, a dot b equals 0 if k is equal to 1/2. So there's an application of those are probably two most common applications, or two of the more common applications of dot product questions you're going to see. One where you have to find the angle, so finding the angle, and then another one, something involving the fact that two vectors are perpendicular and setting the dot product equal to 0.